All right, put your school dress on because we are taking class. Nice. Right here, made in China, contains magical Chinese feathers. Drill 3 times, measure once. I tried to crank this thing just to see if I thought maybe it would start the way it was, and I don't think it would. It just cranks too slow. So pull the valve cover off, have the decompression pulled apart. Here's some math that I did. I'll explain that in a second. So, all right, let me show you what I got going on. So my drill press identifies as a mill machine, at least for tonight. And that worked. Well, this worked, but what you didn't see didn't work because this has a hole in it. And I took that down too far, and it actually like blew a hole in the middle right there. And then I end up grinding it out too far. I might still have to make an adjustment there. But I have another one, and this is a China one, and it's solid. And it looks like it purposely has like a little roll off on it. So this would help oil the decompression mechanism and really nothing else, which that piece doesn't move very much. So, but yeah, we still need to run a drill through there, try to knock some of that out. All right, there's one piece of it. And then the other piece is right here. So this is actually the shank part of an easy out because I ruined the original. So I already made this and it looks like it's gonna work. It's just I didn't this is a copper crush washer that I put on there to keep it the weld in place, but I didn't have this like round enough, and then so when I rounded it out, it didn't really have a good shoulder for like, you know, a footprint on this piece. So I wanted to just dot it up a little bit. So now I'm gonna chuck that in a drill. Probably I might grab my other drill because I think it's got like a more like rounded tip on it. And then we're gonna use like a combination of, we'll grab like this file, maybe we'll put it on the grinder, maybe the belt sander, I don't know. And then we'll get this round and flat to the original profile. And then we need to smooth this up quite a bit. Here's the final product. The copper washer melted into it a little bit, but not in the center where I built it up. So yeah, that process was pretty terrible actually to build that up. I had to do it a couple times and then chuck this in a drill and then carefully hit it with like a die grinder, and then chuck it in a drill, run it on a bench grinder, then run that on a, actually I think I did that with the cutoff wheel too. All right, put your school dress on because we are taking class. So this is the combination of measurements for this mod that made all of this come together and work properly. So the easiest one is the length, okay? And this isn't like it had to be done this way, but it's probably pretty close to like the most efficient way to do it, and I'll explain why in just a second. So the length, that's simple enough. The protrusion to the lobe, that's basically how far this thing is sticking up like right now, okay? And that's what we were trying to achieve, is making it push on that rocker further to open the exhaust valve further. The rod mating diameter, okay? This is also like super important, and I found out that you cannot get carried away with it. And this right here is proof of that, and I'll explain what happened with this one. And then the craziest thing of all was the spring. And me having this other, because I have the China one over here. That was all the China stuff that I just showed you. And so the China spring is like almost 13 millimeters. And that caused a real bind. So let's start in reverse here. Let's start with what the spring did. Okay. So with the stiff spring, basically what it would do is it stays out like that. And then when it comes back, it gets stuck about there, you know, unless it's bumped or whatever. And yeah, when the engine's cranking, it's probably slinging it back. But now with our modified spring, that is, I'll confirm, but I think it's, 10 millimeters. It's only 1 millimeter shorter. Look at that. Comes all the way back. Okay. And something to go in hand with this I didn't talk about yet is I actually grinded the diameter off of this, right? Like I almost flushed it with these pegs here and took that down. I didn't have a before measurement on that, and the after measurement's pretty much the same as this Chinese one. It's probably a little less, probably like 18.5, but it was probably 19.5. And so that's important too, because that's where it locks in. Okay, so basically this is closed. So the more that this can close, the more that this can lock in. And what I mean by that is if I push on this pin, watch this movement of these cams. See that flexed out a little bit? And what I think that flex is a slight roll off on the edge of this where it's not a hard sharp 90, and or the fact that we lowered it. So with this one being much thinner, this was like kind of another revision that I was thinking like I was going to big brain it with like an even bigger pin. This is like an untrimmed pin that I made. The reason why this will not work is this rides on this thing like this. So when it's locked in place, it's basically locked in place like that, okay? And so the more material you take off, it's locked in place like this, and then it gets to the point where it's just like, you know, basic geometry and physics. It forces this to spin, and it goes down, and you can just use your finger and push it down. So if you can use your finger and push this down and get this to like collapse inside of here when it should be resting on here rock solid, then when it comes in contact with a stiff valve spring on it, you know, from a rocker arm, it's every time it's going to do that, which means that this won't work at all. So there is like a fine line where that functions. Okay, and so yeah, grinding out this was to allow this to close up better. The spring allowed it to return to center better, and then the rod mating diameter, basically this measurement here, that measurement is what allows this to collapse and not stick up too high. Okay, so all of those things basically work in unison to make this thing work properly. Alright, just to show you, so this is fully assembled. The bolts are torqued to, I think it was 9 foot-pounds, is what it said. Red Loctite on them. So like everything's assembled. I still want to show you. Still returns to center all the way and bottoms out. It doesn't hang at that spot right there or anything. Nice. Sweet. Oh, nice. Okay, so from the last clip, I don't even remember what I recorded on the last clip. We were fighting with like a hard crank over, okay? And I verified that jumping with 4-gauge jumper cables, I don't know if I actually showed the 4-gauge. I was using like the 6-gauge or 8-gauge maybe in the video, but I got some 4-gauge and I jumped straight to the starter, still a hard crank. So obviously something's not right. We modified the decompression pin, and maybe that helped a little bit. So what I ended up doing is I put this stock cam back in, and then I actually have a couple cams. This is his cam, this was my cam, and I pulled the decompression mechanism out of my cam and tested it with his stock cam in here, and it seemed like it was actually better, okay? But what I realized actually seems to like completely be a game changer is, so right now we have the Mudbuster cam in there with my modified decompression pin, and what I tested on the other cam, which I should have tested like right out of the gate on this one, is obviously that exhaust valve on this side dictates how far that pin touches that rocker arm. And then of course, you know, our cam card, it specifically states to set it to, you know, 10,000ths, whereas the OEM spec is like, I think it's like 6 to 8 or something. So I set that one to like 6, and then it cranked over easier. So now I have this one set to, actually I don't even know what it's set to. I just turned it in a little bit. So this is with it turned in a little bit. Got the plug in there, and so this is turned in. Okay, so that's definitely better, but that's not good enough to use like that. That's still pretty bad. But I had the trickle charger on here. I put it in jump pack mode, and it crank fast. Okay, so two things are happening. Is we still have like the wiring issue, obviously. So I could have went a route with this, instead of trying to dig into here to figure out why the CDI is getting sucked dry on power, yada yada. I could have tapped in here. We go to a relay. The relay is getting raw power from the battery. The relay will then go to a fuse. The fuse will then feed this wire and this wire, right? And then so we get rid of whatever the issue was with this and that. We get rid of that. So we could have went that route. So, but he already had this, and basically to bench test this, what we're going to need to do is we plug this in. We plug this in. I don't even know if we need this plugged in right now, just to hear it crank. And then we plug this in. And then this, of course. But yeah, I think all the relays are for four-wheel drive. We don't need anything else right now. So we only plug in like 4 things to bench test this. And then we'll verify that, you know, whatever is going on, probably somewhere from here to here, is not a problem anymore. And there's a big battery on order, and I think the battery is like 500 cranking amps or something, something silly. It's a big boy. And then so we also have some 4-gauge, okay? We're going to put 4-gauge on all the connectors. So that combination of things should be a fix for like the hard crank over. I mean, I don't know what, I have a feeling it's something to do with the valves combined with the piston, combined with the cam, but I don't know which one's like the major factor. Obviously the piston's a major factor, but I did a Grizzly 600 with that same piston, you know, the 12.5 to 1 on a stock cam probably a year and a half ago, and it cranked over just fine. So, but we didn't do an aftermarket cam, we didn't do aftermarket valves and recessed retainers and change the geometry of the rocker arm and all that stuff. So, and then of course, JE says, oh, I don't know. And then Kibble White says, oh, I don't know. And then Hot Cam says, oh, I don't know. So all of them are just sitting back, sipping their coffee with their diamond spider pinky ring. And they don't really give a shit, because they sell their product to work with probably like a stock application. It's not, their product's not meant to work with this plus this plus this. Like there's no cross compatibility check. They don't care. So, but at this point, I care because it's my problem. I have to make this work. So the way we might make this end up working is through brute force, bigger cold cranking amps, larger gauge wire, and then we might cheat the valve lash a little bit. Like it says 10, we might have to set it to 9 or 8. All right, we got the harness floated. I had to plug a couple extra things in right here. I think it was the sensor on the other side for like the neutral, like basically the safety to tell the CDI, hey, everything's okay. They're being safe. Yeah, there's not a passenger on it. Go ahead and start it up. And other than that, yeah, just the simple couple things I just said. So I tested it with this first. That way, this is like the sacrificial lamb. And it was like crank, click, 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 crank, click, 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 click. And then so I put this one on here. And mind you, like we're not using the chip chopped, and we're not doing a bypass or anything, right? This is all like self-contained in the harness. So I don't have like the dash hooked up or anything yet, but with the new CDI, this is what it's doing. Right, so basically good, not what it used to do. And this is drawing this battery down pretty hard. It's sucking it down to like 7 volts. So yeah, I'd say the harness is good, at least that portion. Check this out before I put it in. It's our new battery. Got this fancy little button on it. 700 cold cranking amps. Like that's insane. Versus 270 AGM lithium. What is insane about this is the weight. Okay, this probably weighs like 10 pounds. Like I'm just gonna do the 2-finger test. It's heavy. Okay. This probably a pound, maybe 2 pounds. Insane. Yeah, this is like for sure just packed full of like magical Chinese feathers right here. Made in China, contains magical Chinese feathers. All right, I had to double check 2 things just so I didn't just record this for no reason and then have to delete it because it didn't work and then mess with it again. But I had to make sure the plug was in it at first because it cranked over so fast. But then I cranked it again and it kind of hit a hard spot. So I think that there's still just that little spot where it's still going to be hard. But as long as you don't start it, like the start of like engaging the starter doesn't start there, doesn't matter at all. Here we go. So you could hear the very first crank. It was kind of like hard to crank over, but then it doesn't matter after that. Sounds a little clacky, but I think that clack is that decompression pin hitting that rocker arm is what I think it is. So just to confirm there's no odd noises that aren't related to that, we'll do that a couple times and it sounds good. No plug in it. Alright, we got some Royal Purple octane booster. It raises at 30 points 3 numbers. And what it says is it treats 15 to 20 gallons. So what we've done is we've taken 20 gallons divided by 3, 6.6 gallons. We've taken 16 ounces divided by 3, and then that gave us 5.3 ounces. And what I was trying to do is I was trying to stair step it down to 2-gallon tanks so I could get a formula. Turns out that turned out to be like perfect, because this was like 1 gallons. So we divide 6.6 by 3 again. Guess what? We're at 2.2. Perfect. So then we have 1.76 ounces, which converts to 52 milliliters. And I got 50 marked on here because I got another one of these where it's not ripped off. This one I used for gas, so it ripped it off. So I've already shook this up, and all I need to do now is pull 52 milliliters out of here. Probably could have got a shorter hose. So that's probably 52. Let's see if I can twist this hose off of here.
Oh, that was bad.
All right, so it looks like it's 50. Probably could have lubed that seal up a little bit. All right, so now this should be 96 octane. This is our first startup. So we've drained the gas tank. We've drained the float bowl on the carburetor.
Have to shake it up.
Gotta shake it up a little bit.
Shake it, shake it, shake it.
All right, I think we're ready for our first startup. We got coolant in it, got gas in it, got oil in it. Everything's ready. The valve lash has been set. We're going to start it up to make sure it starts up. We're not going to run it too long because it said not to let it idle, and it just rained 2 inches and might even be raining right now, so it's not a good day to do a break-in. But we're going to do like a little test fire in here and make sure that it starts up. We're not dripping. Here we go. Sounds beefy. Sounds very, very throaty. Shoo. I bet you that leak is from whenever I pulled this, and this thing was all like crunched up. And I flared it back out and tapped a socket in it. I bet you me tapping it, I messed up that weld right there where it's pinched. So yeah, maybe I could have left that alone and it would have been fine, but I didn't trust the way that was sealed on there. We got other problems too. I tried to clean these fins up, and I mean, it would have worked, I guess. So, probably gonna have to get a new radiator, unfortunately. But that's probably for the best. So yeah, it sounded good. Anytime you put one of them big cams in there, this one ain't really that big, but any cam where you have to set the clearance to like double of stock, it's gonna sound a little ticky. Because, I mean, you got double the valve lash. So I did hear a little bit of a tick, but it's nothing I'm concerned with. It sounded real good. It revved real good. All right, we got a new radiator. And I know what you're thinking. And yes, in a different universe, maybe I could have did this a little bit differently and not cause this leak. And then also too, if I hadn't messed with it and just stuck it on there as a triangle, would it have caused a problem down the road, or was the spot already weak? Also too, if you took it to the dealer, they would have said, oh no, we can't fix that. Oh no, not OEM. And also, I didn't even see all this back here. This is actually pretty ugly on the back side in this particular area. So I'm in the process of stripping stuff and moving stuff over. But this is an upgraded radiator. So check this out. Like 1 1/8. Almost 1 3/4. So he's thick. Damn boy, he thick. Boy, that's a thick ass boy. If you've never seen that, you probably think I'm a weirdo right now. But just type "damn boy, he thick" into Google, you'll see. So anyway, yeah, we're gonna transfer over the sensor. It actually had it came with a plug to cap that off if you wanted to hardwire it, I guess. But yeah, we need to get these little bushings moved over, and then these little threaded clips for the fan, and then we'll get this installed. This was missing these little collars on the top here. So if I went to tighten this down, all it's going to do is squish that grommet out and ruin it. So I made 2 of these to fit down in here. Don't ask me what that is. Just found it in the junk pile. Go back to your home. Okay, it is time. Break-in procedure. Always replace old lifters with new ones when installing a different cam. Skip. If you're running dual springs, you'll need to remove the inner spring to reduce pressure on the lifters during break-in. Very important, only use premium petroleum-based oil during break-in. Do not use any type of synthetic. Check and check. Assembly lube, check. At initial startup, make sure, yada yada. 20 to 30 minute break-in period is recommended. During this time, vary your RPMs between 1500 and 3000. Do not leave the engine set at a steady RPM. Varying the RPM will change the oil splash to the lifters. Once the break-in cycle is complete, you're ready to ride, but for the first 3 hours, do not operate at full throttle or high speeds for extended periods. All right, let's go drive around for a minute. pipe temps are good, right around 500. I don't think we're fully warmed up yet. Alright, we got the fan to kick on, verified the fan's good. Temps are all looking good. This thing rips pretty good. It's pretty snappy. Even with them big tires. I don't even know if I touched base on these tires, so obviously we were sitting on rims and he dropped these off. And crazy story about these is these used to be my tires on a Big Bear from years and years and years ago, and this guy tried to buy the tires off of me, and I told him, you know, it'd cost him $2,000 or whatever I was selling the Big Bear for, and it comes with a four-wheeler. And that was like the first time we ever talked, and turns out he actually bought these off of the guy I sold that four-wheeler to, and they've just been sitting for years. And I got a crazy patch in one of them right here. You ever seen a patch like that? It's a carriage bolt, some stainless steel washers and windshield urethane on the inside. I went to a park and towards the end of the day realized I had a flat tire, and it had like a split in it like this wide, and so I was like, well, you can't plug that, I'll have to pull that and patch it from the inside or see, you know, what's going on, because I didn't want to buy a $200-300 tire. And turns out it was a whole stick like this long. It's like probably that big around that went through the whole tire. Wild. But yeah, this has been holding up for years. Maybe a little flat right now, but it does its job. All right, it's your YouTube channel now. Take it away.
Yep. For a day channel, we are going to use some bolts.
Loosen some bolts?
Yeah.
So we gotta take the whole engine back apart and put the inner valve springs in, don't we?
We have to take a whole engine and put valve springs off. All way I'll use it, this one is, you can't see it, it's right here. I kind of like up this way. And we just about to take that off like that. Nope. Get off, little piggy.
All right, tell them what you did.
I shook all shoes off right here, and I shook these off, and now we got to bank off.
All right, So everything you just saw, I did that again, basically, most of it to get these springs back on. And we're at the stage where we are going to apply the 3 bond properly this time, because we only did it on one surface last time because we didn't really care if it leaked or not, because we were going to tear it down again. So now that we're going to do it proper, there's actually a couple things to note. There are some key spots where you will get seepage if you don't pay attention to, like potentially right around here, this tiny little area. It can, like, oil can seep into there and then seep into here and then come out the bolt hole. Same for, even though this is like sealed inside the engine, it can like seep up through the bolt hole, so we want to get it around there. And then this corner right here is important. See that? Like that tiny little bit can leak over into that bolt hole. And then same for like this edge right here. So this has assembly lube on it to where if we get this too close and hit this, it's not going to stick to it. It'll be alright. We're not going to waller it in there, but if we get a little on there, it's going to live. So yeah, all of those little tiny spots are actually super important. So what we're going to do is basically, we're going to put it on here first, because this is going to be trickier than doing the valve cover. And then we're going to do the valve cover. And then on the valve cover, we want to get it all the way up into here on this spot. This is like really the only spot on this, because this is all flat and you pretty much smother it around. But yeah, up in these corners right here. And then of course, make sure that it's been degreased, because anything that has grease on it, or oil on it, it's not going to stick to it. So on the camshaft, we use that as to our advantage. Here, we just pay extra close attention to these corners. Put grease on these things before you put them up in here and they won't fall out. They'll smoke a little bit when you start it. Okay, so we are at the point where just basically put all that on, and we got that pulled. And this is basically like the first step, is to get this like grill on with the headlights. So we're getting the headlights adjusted right now. I'm just kind of lining them up with a brick on my wall. I guess it's time to peel these off. I'd say it looks pretty even. And then the next step is going to be getting this ductwork on here. And then this area has got to be clear. I don't think it was. I think it had wire, because you can see where it's like clean. But I also don't think it had that bolt in it. And then these need to be clear. For it to, it'll fit here, and then piece will fit here. It should be flush. Alright, so I got the front plastic on, bolted. I had to redo quite a bit of wiring. So there's the dash cluster that needs to be like on the outside. I got this fished up through here. It's the fan connector right here. Once I got the plastic bolted to this like clip for the headlights, then it shifted the headlights, and then I couldn't get the headlights adjusted because of just like the angle. So I drilled a hole right here in the plastic. Just big enough to get a screwdriver in there to adjust that, which is how it should have came from factory, in my opinion. So now we're gonna mock this piece up and figure out where we're gonna need to cut because the way I have this routed, I think I'm going to have to put a hole right here. And ideally, maybe put a hole, either cut it out like in a rectangle, or put a hole in the same spot on both sides so it looks pretty. I'll figure that out real quick. So there's no way I can make like the holes even or anything, so all I'm doing is I'll do like that. Basically eyeball it. And then this one, we're just going to go center of that hole. Because the center of that hole, I already centered it in between that. And then probably make this hole an oval, and we'll fish this connector through there. Same for this connector as well. And then over here, instead of trying to force this at a crazy angle, it already wants to go that way. We're just going to, same thing, line it up center of that hole. Just basically go straight down to where it'll have a slight curve instead of a sharp curve or trying to fish it over that. Go down a hair on this one too. Drill 3 times, measure once. Alright, so everything turned out good. So I just need to snip the excess off. And the only problem we have currently is this connector and the harness side connector does not have enough room. So what I'm gonna do, because the harness side connector for this is actually tied into like the servo for the front differential, and I mean it's just like this long. So I'm just gonna cut this and extend this. That's all. We're just gonna extend that. We're going to fish it through this same hole, and then it'll connects kind of up in here. It's this connector right here. So, I mean, I can get under here and clip it in. It's not like too impossible or anything. Alright, so I actually had to make some rubber washers and put them underneath this, because without doing any of this, you go around and the engine vibrating. It's all kinds of this thing is just noisy. So I've pried this up a little bit, and then this has got a gap. Pry this up a little bit, and then come in here and pry this up a little bit. Just make sure all this stuff's floating, and then just smack it and make sure it doesn't sound like that, whenever you're bumping it. That way the engine vibration won't make any crazy noises. The real test is going to be obviously to drive it, but I think it's going to be silent. Let's try to fix this a little bit. Oh, it's getting close. and not so much on this side. We got to leave that open. We're going to do a little bit of tinkering with the air fuel screw, because if you just go whop, yeah, and it's in gear and it actually like lunges, it wants to die. It doesn't really do it in neutral. So we're gonna see if we can tinker with it just a little bit. But this is one of the final pieces that needs to be addressed. So this was like the band-aid, and this one has been a trooper through all of the bad things. Did a lot of bad things to this. So there's no reason in getting a new one, because a new Chinese one's going to be worse than whatever this is. I think this is an OEM. So I did manage to keep this safe. So all we have to do is line up where it's broken, and then line up this little chunk here that's missing, and we're going to super glue that on there, and then we'll silicone it to waterproof it. And then on top of that, I think I'm still going to wrap a zip tie around it like the way it is right now, just because I don't think the super glue is as good as whatever they did from factory. But yeah, we're going to keep using this if it still works. So doing a couple little after the fact things. So if you see right there and right there, those are atmospheric vents for the bowl. And basically I just have a piece of tube hooked on that, and then they just kind of loop over the gas tank right there. And that's to keep water from getting like splashed up into there. And then this is a one-way check valve. It's a little bigger than what should be used for this little float bowl nipple. But we're just going to trim this, shove that on there with a clip, and then these two are jammed in tight. They're not coming apart. And so what that'll do is it'll keep it from where if the water line gets above this bowl, it can actually come up through here. So this is for the overflow, where this drain does two things. It drains from this if you crack that loose, but it also drains automatically from here, always, no matter if this is tight or not. So those are a couple things that people miss a lot of times whenever they snorkel it. And yeah, we're not snorkeling it, but we don't want this thing to stall if it gets in like deep water or something. Okay, I just decided to run this right here. So this spot here is kind of bare and vulnerable. If let's say you were turned all the way to the left and something was caught in one of these lugs, it could hit those hoses. And I think there's actually a piece, like a stock piece that goes there, but I made this for him last time. It's like a piece of yard edging, and basically just kind of like fits down in there. And then you just like run a zip tie through here, and then run a zip tie through that frame rail down there. And it's like the perfect deflector piece. It kind of matches too. It's not really that bad or anything. We'll just top it off. But I think it looks watery. I think it's got water in it. That's a neat color. What even happened to this drain plug? Look at it. It's got like chunks taken out of it. So somebody hit that with a chisel. I cleaned it up a little bit to where it won't destroy a fresh crush washer. We'll just check on that here in a little bit. Okay, so we are doing a little test and tuning. The blip and it kind of dying is because that air fuel is too rich, so we've actually backed it out. I think we're only like a half of a turn out, and it seems to be where it's happy. So we're gonna do like a test rip before we pull this airbox lid off. We're gonna take the airbox lid off for testing because it's got a 170 main in here and it's puffing a little bit of black smoke, so I mean it's obviously rich, and we're gonna leave it a hair rich, but I think if we pull this lid off this thing, it's just gonna kind of like awaken the beast. So we did lose like a hair bottom end, leaning out the pilot a little bit to where it doesn't have that stumble if you just, you know, do quick snaps, which this thing is very responsive, so quick snaps are very fun. So now it doesn't die anymore, and that's more important than, you know, getting a little more seat feel. So we're gonna do a quick rip, and for you probably a sound test of what it sounds like wide open, and then we'll do with no airbox lid. All right, how about, buddy? So it's definitely fast. We are self-clearancing the fenders as we go. Looks like it ripped out some zip ties.
Almost touched the tire.
Yeah, tires are too big, aren't they? Alright, here's what the lid removed. I was gonna say I honestly can't really tell a difference, but then, so since it wasn't anything massive and this thing's meant for like bottom end mid-range anyway, we're just gonna put the lid back on there. surprised I could do it. Okay, so the purpose of this is if you are stuck in reverse, especially on like a downhill, like your ass ends up, front end sunk, and you got some big mud tires like this, and you put it in reverse and you hit it hard, this is where it lands. All right, so the relocate's great for like plowing through, but if you need to back up and you're in some slop, it's not going to do you much good other than it's easier to clean off, right? And so what this does is when it's thick like that, it hits this and it does not fall through this, at least not very much, not compared to the expanded steel. So the expanded steel, it can fall right through there and it'll just clog the radiator up. It might as well have been down there. It's just easier to clean. So you have this on here, you get that packed, and this is going to be making heat, so it'll dry that real quick. Once it's dry, you just take this thing and you just pop it and then flake off all that mud, and then bam, you're ready to go. You don't need a creek, you don't need water, you don't need anything. You just let that heat dry it and then knock it off and get back to it.